All right, let's finish up this unit with combustion reactions. I saved the best or the easiest for last. They will always start with a hydrocarbon, which contains carbon and oxygen. Sometimes they'll have, I said carbon and oxygen, I meant carbon and hydrogen, although sometimes they will have oxygen. The best part is that they always make the same thing. So they're always going to have carbon dioxide and water as the example, as their product. Excuse me, I'm having some internet issues. So always going to make CO2 and water. So here's an example of one that's balanced for you. And so let's do a couple examples because they are the easiest. Okay, these first two examples, we have C3H8 plus O2. Again, always going to make CO2 plus water. So you can always just write that down when you see a combustion. So there is a trick to this, and that is going to be we're going to always balance the oxygen last. So I always look at my hydrogen right here, and I see what am I going to need to put in front of water. Because what I'm going to need to put in front of water is very important. Because this O2 right here has a 2 behind it. No matter what number I put in front of that, it's always going to be an even number. Because anything times 2 is going to be an even number. Same thing with this O2 right here. The problem becomes this oxygen here at the end. It's only one of them. And so it's an odd number. And so I'm going to have to make that side be an even number in order to get my equation to balance correctly. And so I always look at my hydrogen first and see what number would I have to put in front of water. And if it's an even number, then I proceed. But if it's an odd number, I would do something different, which I'll show you here in a second. Okay? So I see that it's an 8. And so in order to make this water over here, where I've got hydrogen, be 8, I would put a 4. And so since it's an even number, I'm just going to proceed on. Then I look and see I need 3 carbon, so I put a 3 right here. And now I will add up my total amount of oxygen. So I have 3 times 2, so I have 6 oxygen here. And then I have 4 oxygen, because remember this 4 goes for everything behind it. So 6 plus 4 is 10 total oxygen on this side. And so I need to make the other side be 10 total oxygen. And so I can easily do that by putting a 5 right there. And so now my equation would be balanced. Okay? So let's do the next one. This one is an alcohol actually with this OH group in here. So still going to make CO2 and water. All combustions always make CO2 and water. Okay? But this time it has this OH here. So now the odd thing isn't necessarily going to be an issue, but we're just going to have to play around with it. So these are like a puzzle, okay? So you just kind of have to play around with them. So I'm going to try it first with 1, and I'm going to see that if I put a 1, if I keep 1 in front of here, okay, then I would need a 3 here, and then I would need 7 plus this one right here is 8, so I'd need a 4 here, okay? So now I've run into that I'm going to have 4 oxygen here and 6 here, okay? So I need 10 total oxygen, okay? But if I try to go get 10 here, if I can't just put a 5 here because I have this random oxygen right there. And so again, I'm going to run into that even odd thing. So I see that it will not work. So anytime I see that it's not going to work with 1, then I'm going to bump it up and I'm going to change colors here so you can kind of see. I'm going to try it, say, okay, that's not going to work, so I'm going to put a 2 here. And then when I do a 2 here, that means I'm going to need a 6 here now, and I'm going to need an 8 here now. So now I'm going to do my new count of oxygen, and I'm going to see that 6 times 2 is 12, plus 8 is 20, okay? So I can go over here and see if I can get 20. Well, I already have 2 right here, so minus 2 means I need 18 more. Well, half of 18 is 9, so I'd put a 9 here. So my final answer for this equation would be 2, 9, 6, and 8. Okay? So let's do 2 examples from your left side. Actually, I think I might throw a third one in there for you. Oh, these are down here. These are just some common of the hydrocarbon names, so you can kind of recognize them. It's just there for you to see, so you would recognize, like for instance, You know, when you talk about gasoline and they talk about a high octane content, that's the formula for octane. Methane is natural gas. That's what we burn. You've heard of propane and butane as well as fuel sources. So those are just some examples of those so you can see those. So now let's work the examples. Okay. First example is number 4, and that is butane, C4, plus oxygen. Whenever you see plus oxygen, remember that means you're going to have to do O2 because when it's by itself, it's diatomic. So we're going to do C4H10 plus oxygen, always making CO2 and water. All right, and so now we're going to try to balance that. Always check your hydrogen. I see that it's 10, so I'd have to put a 5 in front of water, which isn't going to work because that would keep water odd, or the oxygen odd. So I'm going to automatically bump that up to 2. And then 2 times 10, I'm going to need 10 for water. I've got 2 times 4, I need 8 for carbon. And now I do 8 times 2 is 16 plus the 10 oxygen from water for a total of 26 oxygen. So now I'm going to need 26 on this side over here. And so half of 26 is 13, so I would put a 13 right there. Okay. Hexane, C6H14 plus oxygen. Again, we've got to write it as O2 because it is diatomic, always making CO2 and water. Okay. And let's balance it. Again, I look right here. I see that that's 14, so I would have to put a 7 over here, and that's not going to work because it's odd. So I'm going to automatically bump this up. And then I would see that I need 14 here. Now my hydrogen's balanced. I need 6 times 2, 12 carbon. And now I do my math count for oxygen. I have 12 times 2 is 24 in this side, plus 14 gives me a total of 38. So I need 38 oxygen over here as well. And so with this 2 right here, that means I would take half of that and put a 19 right there. Okay, let me go ahead and do one more. I think I'll go ahead and do number 5 on your left side activity. I'll go ahead and do that for you. Okay, so let's do that right up here, number 5, which says it's pentane, so that's C5H12 plus O2, going to give us CO2 and water. All right, now I look at my hydrogen, got 12. Half of 12 is 6, so I'm good because it's an even number, so I can proceed. I have 5 for carbon, so I put a 5 here. Now I do my oxygen count. 10 plus 16 is, 10 plus 6 is 16, so I need 16 over here, so I would put an 8 there. Combustion examples from the lab, there was really only one, and that was when we did our Bunsen burner. And our Bunsen burner, we said Bunsen burner burns natural gas. And so that, I think that's actually the first question on your lab. And that is CH4 plus O2. And that's going to yield CO2 plus H2O. And if you're really paying attention, you'll notice that that was the very first example that was already balanced for you in the combustion section of the lab. So just take a look over there and you already have that one reaction done. All right. All right, so this is kind of a wrap-up. Let's kind of practice this together. In this section, we're just going to say what kind of reaction we have. If we have decomposition, single replacement, double replacement, combustion, or synthesis. Okay, so let's start with this one. Anytime I see that I have only one reactant, that is going to be a decomposition. That is our clue for decomposition, is that there's one reactant. Okay. We just did these, so hopefully you recognize that that's a combustion, because we just did them. That's going to be combustion. Number 3 has an element plus a compound. Anytime I have an element plus a compound, that's going to be single replacement, and we'll abbreviate that. I have 2 simple elements. Okay, 2 elements plus each other are going to always be a synthesis, because the only thing they can do is form a compound, because they're just 2 elements. And then the last time I have 2 compounds, and that's going to always be double replacement. Okay, on the next slide, we'll actually predict what they're going to make and balance these same reactions. So now that we know what they are, let's predict what they'll make. Aluminum chloride is going to break down because it's decomposition, and the only thing it can break down into is sorry about that, I did that again, is aluminum, okay, plus chlorine. And when chlorine is by itself, remember it's a Brinkelhoff, so we're going to write that as Cl2. So we always predict, then balance. Remember that. So now we're going to balance that. I have a 3 for chlorine and a 2 right here. The only way I can get that balanced is to do a combination to make it 6. I'm going to put a 3 there, and I'm going to put a 2 here, and then that will require a 2 there. Okay. Next one is our combustion. So of course CO2 plus water. I look right there, and I've got an even number, so I can proceed by putting a 2 here, and I have 2 carbon. So now I have 2 times 2 is 4, plus 2, I have a total of 6 oxygen, so I need a 3 there. Okay, single replacement is the next one. Remember, I want to see, will silver be replaced by zinc? If you look at the activity series, it will, and so I would get zinc nitrate, which is a plus 2 charge, so I need 2 nitrates, and then that would kick out silver by itself. And so now I need to balance it. Remember, we treat our polyatomic units all as one thing, like right here, and so I'm going to say I have 2 nitrates there, so I'm going to need 2 nitrates there, and then that's going to force me to put a 2 there for silver. Last one is aluminum, not last one, the next one is aluminum plus phosphorus, and so I would put those together in a way that I know. Remember, when aluminum is in a compound, it forms a plus 3. Phosphorus forms a negative 3, so it's literally just going to form ALP, ALP. Okay? Nothing needs to be balanced because everything is 1 to 1. And then the last one is a double replacement. And remember, double replacements, we do outside, inside things together. Does not matter which one you write first. You can write the outside things first or the inside. It doesn't matter. I just typically tend to do the outside first, but that's okay. So we do sodium nitrate, and then we do silver chloride together. Okay. Remember, on the double replacements, we have to go see what's aqueous and what makes a solid. Sodium is a group 1 metal, always soluble. And remember, when we saw soluble, we write that it is aqueous because it stays dissolved in water. And then we go check our solubility rules, and we see that chlorides are always soluble unless there was silver, lead, or mercury. And so this is with silver, so it would make a solid. Because remember, if it's insoluble, we write that it makes a solid because it falls out of solution. Okay, and this one we're just going to write what it says. And so we're going to do sodium metal, so that's going to be Na is placed into water, H2O. Okay, and then we know that when water breaks apart, remember it's HOH, kind of like that. So this is a single replacement, so we want to know, will sodium replace hydrogen? But really we're going to place just one of the hydrogens, and it does. It's actually very volatile. So it forms sodium hydroxide plus now hydrogen gas, because it's kicked out that one hydrogen and it has to go as a gas. And so now we balance it. Okay, so I have 3 hydrogens over here, and on this side 1, and then these 2, and I only have 2. So I'm going to fix that by putting a 2 here, which makes me put a 2 here. Now I have 4 hydrogen and 2 oxygen, so I need a 2 there. Okay, this one, methane gas, we've done that a couple of times. You can look that one. You should already have memorized by now. Methane is O2, and then it makes CO2 plus H2O. I put a 2 here, and a 2 here, and that balances. And then the last one is KBr plus chlorine gas, chlorine by itself, Brinkelhoff. We want to know, will chlorine replace bromine? Because remember, nonmetals replace nonmetals. Okay? And if you look at the activity series, it does. So we would get potassium chloride now, and bromine would be by itself, Brinkelhoff, so it has to be together. So to balance that, I do a 2 and a 2. All right, and that completes our notes. You have a test coming up, so you're going to, if you need to watch these videos over and over until you get it down, you can. Also, there's some YouTube videos out there, and I wish you luck on the test. And I miss you guys.